So you guys toughed out yesterday using no calculator with the rational root theorem, and today you get to use a calculator. So make sure that you have a graphing calculator. I will be using the TI-83 Plus. If you have something similar, the buttons should be about the same. They just might be in a different location. So punch around. If you need to Google something on your phone, feel free to pause this video and do that to find those buttons. So the first thing that we want to do is we want to list all the possible rational roots. Yesterday we talked about the P and the Q values. Remember, the P, those values come from all the factors of 15. So all the factors of 15 would include 1, plus or minus 3, plus or minus 5, and plus or minus 15. Then all of the possible factors for Q being our 4 here, the possible factors there would be plus or minus 1, plus or minus 2, and plus or minus 4. So to find the possible rational roots, we take P divided by Q. That gives us plus or minus 1 divided by 1 is 1. Plus or minus 3 divided by 1 is 3. Plus or minus 5 divided by 1 is 5. Plus or minus 15 divided by 1 is 15. Then we go on and treat 2 as the denominator. These values here are our numerators. So we say plus or minus 1/2, plus or minus 3/2, plus or minus 5/2, and plus or minus 15/2. Then we do the same thing only for the 4s. Plus or minus 1/4, plus or minus 3/4, plus or minus 5/4, and plus or minus 15/4. Now if there's anything that you can reduce there, remember you don't have to write a possible rational root more than once. Always look to the exponent. The exponent tells us a couple things. If this is a degree 3, the maximum possible rational roots is 3. So out of all of these values, the maximum value roots that we could find would be in total 3. We can use our graphing calculator to eliminate a lot of these. Yesterday we kind of had to do it by brute force. Today I want you to go ahead and just graph that on your graphing calculator. So turn on your graphing calculator. If there's something in the y equals function, feel free to delete that out. Right here is your y equals button. This is where we type in what the equation is. The equation here is 4x to the 3rd power minus 20x squared minus 3x plus 15. Then go ahead and graph that. Sometimes the graphing calculator will be zoomed in really far and zoomed out not so far. If you want to at any time just bring it back to normal, I like zoom standard, which is number 6 here. So just arrow down to 6, press enter, and you kind of get a standard window of what you're looking at. Now sometimes it's nice to actually zoom in a little closer. Press zoom, go down to zoom in. We can kind of see where those graphs cross. Now here, you know what, looking at my possible rational roots that we have listed, I don't really want to make a guess. Those don't really cross nicely. So let's see what, there was that other place that it crossed. I saw it was kind of down over here somewhere. Okay, so 1, 2, 3, 4, 5. It looks like it crosses at x is equal to 5. I can check to see if this really is a value by using synthetic division. Now, I do not change the sign because I've already have said that my estimated value is x is equal to 5. Remember, when it's in the set of parentheses, it looks like this. Okay, so here's my 5. Let's set up synthetic division. Looking at the exponents, 3, 2, 1, 0, they're all accounted for, so I take the coefficients of every term. 4, negative 20, negative 3, and positive 15. Bring the 4 down. 4 times 5 is 20. Add down, we end up with 0. 0 times 5 is 0. Negative 3 plus 0 is negative 3. Negative 3 times 5 is negative 15. Remainder 0. Good, that means that we have a root. Whenever there's a root, it will divide out of that original polynomial evenly. So now we've been left with, remember this was x cubed, and down here this is x squared. So if I were to rewrite this, this would look like x minus 5 times the quantity 4x squared, 0x, which I don't need to write, minus 3. Since I'm finding the zeros, we set that equation equal to 0. Now, to find the rest of the zeros, I already know that I can set x minus 5 equal to 0, where x is equal to 5. That worked for us using synthetic division. I can also take this set of parentheses here, this 4x squared minus 3, set that equal to 0, then go through and solve for x. 4x squared is equal to 3, which means x squared is equal to 3 divided by 4, leaving us with x is equal to plus or minus the square root of 3 all over the square root of 4. Now we can simplify this down to plus or minus the square root of 3 all over 2. This is not a rational root, but it does give us the zeros here. So our x values, x is equal to 5, and it's equal to plus or minus square root of 3 all over 2. If you notice here, we have how many roots? Well, my degree was 3, and I have 1, 2, 3 roots. Because remember, you have the plus radical 3 all over 2, and you have minus radical 3 all over 2. If at any time you wanted to check that value, remember we can always second quit out of this. And then you can type in, what is the square root of 3 divided by 2? Oh, it's about 0.8. Didn't that graph look, when I zoomed in here? It looks like it's at 0.8. So chances are you've solved it out correctly. Great work. Let's go on to the next one. Once again, we need to list all the possible rational roots here. If you go through and you find all of your factors of p, all of your factors of p, or your values for p, include plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 13. These can all be found by just taking 78, seeing what numbers divide into 78. So type into your calculator 78 divided by 2, 78 divided by 3. And if it comes out evenly, then it is a factor of 78. Plus or minus 39, plus or minus 26, plus or minus 78. Now the values of q are all the factors of 1, which is plus or minus 1. So it just happens at this time, since there's a 1 in front of this leading in front of the greatest variable, the variable with the greatest exponent, that leading coefficient is 1, meaning that all of the p values are the possible rational roots in this case. So let's go ahead and graph this. I'm going to clear out the graph that I just did. I'm going to say x cubed minus 2x squared minus 35x plus 78. Well, I know that this has 3 roots to it. Okay, whether those be imaginary or real, we have yet to find out. So let's zoom this standard to see if we can estimate. Oh, good. There are 3 places where it crosses that x-axis. Over here, it looks like it crosses right at a certain point. So I'm going to see if that is one of my possible rational roots. 1, 2, -3, -4, -5, -6. So I'm going to say -6. That was really close. Let's try it out. Synthetic division, 3, 2, 1, 0. Take all of the coefficients. 1, -2, -35, and 78. 1 times -6 is -6. Add down and we get -8. -8 times -6 is a positive 48. 48 plus a -35 is a positive 13. Positive 13 times a -6 is a -78. Add that down and we get 0. So now we're looking at something, x plus 6 times the quantity. Now remember, this was an x cubed, meaning down here this is an x squared, is x squared minus 8x plus 13. We are trying to find all of the zeros, so set it equal to 0 in order to solve it out. This first term, we already can see that x is equal to 0. We can say x plus 6 is equal to 0, which means x is equal to -6. Now for this second set of parentheses, can you think of anything that multiplies to 13 and adds to -8? Nope, neither can I. So I'm going to use a quadratic formula for this. X is equal to -b plus or minus the square root of b squared minus 4ac all over 2 times a. So that means x is equal to 8 plus or minus the square root of 64 minus 52, all divided by 2, which gives us x is equal to 8 plus or minus the square root of 12 divided by 2. We know that 12 factors, another way we can rewrite that, is 2 square root of 3 all over 2. Since all of those exterior values, all those exterior terms are even, you can divide all of those by 2, and we are left with x is equal to 4 plus or minus the square root of 3. And x is equal to -6. So there are my 3 zeros, which makes sense because this is a polynomial of degree 3.